Have you ever wanted a shortcut to truly understand the cutting edge of AI? You know, get beyond just the daily headlines.
Hmm.
Well, today, we're aiming to give you that shortcut.
Okay.
We're taking a deep dive into the latest from Google DeepMind's Gemini team, specifically their new Gemini 2.x model family.
Right. The 2.5 Pro and 2.5 Flash are the big ones here.
Exactly. And our mission for this deep dive is to really unpack the innovative engineering, the breakthroughs that are pushing the frontier of what AI can do.
And also how they're being tested, right?
Yeah.
Capabilities and safety. That's crucial.
Absolutely crucial. And just so you know, all our insights today, they come straight from the Gemini 2.5 report. That's from the Gemini team at Google, dated June 17, 2025. Gives us a real look under the hood.
Yeah, it's a dense report, but what's fascinating is how it lays out not just what the performance gains, but the how, the foundational shifts.
It's not just better, it's built differently.
Exactly. It feels like a different approach.
Okay, so for you listening, let's start with that big picture. What makes this Gemini 2.x generation really significant? We've got Gemini 2.5 Pro.
Which they're calling their most capable model yet, hitting state-of-the-art SoTA performance.
On some seriously tough benchmarks too, coding, reasoning.
Yeah, the really hard stuff. And then there's 2.5 Flash.
Which offers what? Excellent reasoning, but cheaper and faster?
Pretty much. Great performance, but much lower cost and latency. And then you have the 2.0 Flash models kind of rounding out the family.
So they talk about this family covering the full Pareto frontier. What does that actually mean in practice?
Well, think of it like optimizing choices. The Pareto frontier represents the set of best possible trade-offs between, say, capability and cost.
Okay.
So instead of just one mega model, they're offering options all along that optimal curve. High power here, high efficiency there. It's strategic.
Got it. So there's a model for different needs, but they share a core philosophy.
Right, and that core is natively multimodal. They understand text, audio, images, video, all together from the ground up.
And huge context windows, over 1 million tokens.
Immense context, yeah. Plus native tool use. So they can look at like entire code bases, not just snippets, or hours of video.
Wow.
And that foundation, that's what unlocks these more complex agentic workflows, moving beyond Q&A to actual problem solving.
That native ability to handle all that context and modality is, well, it's astounding. But let's get into the how. The architecture. What's really enabling this? I keep hearing about sparse mixture of experts, MOE.
Oh, MOE.
Yeah.
That's a core innovation here.
What is it exactly? Why is it such a breakthrough for these huge models?
Okay, so imagine you have a huge team of experts, right? But for any given problem, you only call on the specific specialists you need, not the whole team every time.
Okay, makes sense.
MOE is basically that for AI models. It lets them have enormous potential capacity, tons of parameters, tons of knowledge, but only activate a small, relevant subset for each specific input token.
So it decouples size from compute cost.
Exactly. You get the benefit of scale without the massive computational hit for every single calculation. It's a huge efficiency gain, especially for training and running these frontier models. It fundamentally changes the scaling game.
That's a really powerful shift. And speaking of the hardware side, these are the first models trained on Google's TPU v5P.
That's right. Their latest generation of custom AI accelerator chips.
So faster, more efficient hardware tailor-made for this kind of AI work?
Essentially, yes. Built for massive scale and efficiency. Using TPU v5P shows the level of investment and, frankly, ambition behind Gemini 2.x.
And training models this big must take ages, right? What happens if hardware fails? Which it must, constantly, at that scale.
Yeah, that's where this other really neat innovation comes in. They call it slice granularity elasticity.
Okay, sounds complex. What does it do?
It's actually a brilliant solution to an inevitable problem.
Yeah.
Hardware failures happen like multiple times an hour on these huge clusters. Previously, a failure might mean stopping, rescheduling, maybe losing 10 minutes or more each time, which adds up incredibly fast.
Right, that could derail the whole thing.
But with this elasticity system, if a slice of TPUs fails, the training doesn't halt. It automatically reconfigures and keeps going with the remaining healthy slices.
On the fly.
Yeah, almost instantly. They lose maybe tens of seconds instead of 10+ minutes.
That's incredible.
That means they can maintain something like 97% training throughput even with failures. For runs that take months, this saves potentially weeks of time. It accelerates the whole R&D cycle.
Just a massive boost in operational resilience. Okay, so the architecture and infrastructure are cutting edge. How do they actually refine the models during training? making sure they're high quality.
So that gets into their post-training methods. Supervised fine-tuning, SFT, reward modeling, RM, reinforcement learning, RL. Standard techniques, but they've made advances.
What's innovative there?
One really interesting thing is using the model itself to help with quality control.
How does that work?
Well, the model might help generate better training data or critique its own responses, making the feedback loop faster and more nuanced. They've also thrown more compute at the RL stage and improved the algorithms for stability.
And that led to better performance.
Significantly better. They mentioned over 120 L-Arena ELO points gain for both 2.5 Pro and Flash compared to the 1.5 versions.
Okay, for those of us not deep in the AI leaderboards, what does 120 ELO points signify? Is that a lot?
Oh yeah, it's substantial. Think of ELO like in chess rankings. A 120-point jump means a very clear, measurable improvement in head-to-head performance against other top models. It's not just a small tweak.
Got it. So foundational engineering leading to real performance leaps. Let's switch gears slightly to the capabilities themselves. Gemini 2.5 Pro is called a thinking model. What does that actually mean?
It means reasoning isn't just an add-on, it's baked in. And crucially, its performance can scale with inference time. Give it more time to think, it can potentially arrive at better answers.
How does it do that?
They developed a new approach called Deep Think, specifically for 2.5 Pro.
Deep think.
Okay, and what's really novel here, academically speaking, is that it blends parallel thinking. The model generates multiple potential answers or hypotheses simultaneously,
Okay.
and then it critiques them. It sort of debates internally before settling on the final response. It's mimicking that iterative, self-correcting process we use in complex problem solving.
So it's not just pattern matching, it's analyzing its own potential outputs.
Kinda, yeah. It moves towards more robust first principles reasoning.
And the impact. Does this deep think actually deliver?
Apparently, yes. It's what's allowing 2.5 Pro to hit SoTA on really hard benchmarks. Things like Olympiad math problems, USAML level, incredibly tough.
Wow.
In competitive coding like Live Code Bench and complex multimodal tasks like MMMU, these aren't tasks you can solve with a quick guess. They need that deeper reasoning.
Speaking of code, the report really emphasizes a strategic shift there,
Yeah.
delivering real-world value in software development. What's the innovation driving that?
It seems like a very focused effort. They talk about incorporating much more diverse code data in pre-training, using new training techniques that link code with reasoning, and curating specific complex engineering tasks for the model to learn from.
The goal being a genuine developer assistant, not just a code completer.
Exactly. And the results they report are, well, they're dramatic.
Yeah, I saw those numbers.
Yeah.
Live code bench jumps from about 30% for 1.5 Pro to 69% for 2.5 Pro.
Huge leap.
Aider polyglot goes from like 17% to over 82%.
That's done shit.
And SWE bench verified from 34% to 67%, plus a 500-plus ELO jump in Web Dev Arena. These aren't small gains.
No, absolutely not. It's just a fundamental shift in the model's ability to handle complex real-world coding challenges.
Okay, beyond text and code, what about multimodality, especially video?
Yeah, big improvement there too. They expanded the video data used for both pre-training and post-training. And 2.5 Pro can now handle up to 3 hours of video in that million-token context window.
3 hours?
Yeah.
Isn't video incredibly data-intensive?
It is, but they found a way to be much more efficient. They use fewer visual tokens per frame, 66, instead of 258 in the previous model, apparently, without losing significant understanding.
That efficiency is key. What kind of new applications does that unlock?
Well, the report gives examples like generating interactive quizzes from lecture videos. Or creating P5.js animations.
P5.js, that's the creative coding library.
Right. Imagine pulling key concepts from a video and turning them into visuals automatically. The educational potential seems enormous.
They had that example of finding a tiny detail in a long video, right?
Yeah, recalling a specific 1-second event, the color of a t-shirt a robot was folding from a 46-minute video, and pinpointing the exact time code. That level of detail is pretty amazing.
Definitely. What about long context itself and these agentic capabilities?
The 2.5 models are significantly better on tough long context benchmarks like LFT and MRCRv2, hitting SoTA quality. And crucially, the report states they're the only models among the competitors tested that reliably support that 1M plus token context length.
Being able to ingest and reason over that much information is a superpower.
It really is. And they're building on it. This Gemini Deep Research Agent built on 2.5 Pro.
What does it do?
It's designed to tackle niche queries by strategically browsing the web, figuring out the best search path, identifying dead ends, sort of like an AI research assistant.
And his performance improved dramatically.
Yeah, on the Humanities Last Exam benchmark, which tests complex, open-ended research questions, its score jumps from under 8% last December to nearly 27% in June. That shows real progress in agentic problem solving.
And finally, tying reasoning and factuality together.
Right. Gemini 2.5 integrates that advanced reasoning with native tool use, specifically Google search.
So it doesn't just rely on what it was trained on.
Exactly. It can formulate specific search queries, pull in fresh information from the web, synthesize it, and answer complex questions that require up-to-date facts or multiple steps of reasoning. It actively finds and verifies info.
And this is already out there, powering AI overviews and the Gemini app.
That's what the report says. Powering experiences for billions and hundreds of millions of users, respectively.
Okay, so we have these incredibly powerful, innovative models. Let's shift to the responsibility side. Safety, security, evaluation, this is critical.
Absolutely.
The report makes a point of saying the 2.5 models maintain strong safety, but are also much more helpful and less likely to give those frustrating, overly cautious refusals compared to 1.5.
Yeah, addressing that balance is a key challenge. Being safe and useful.
How are they training for that?
It's a multi-pronged approach.
Yeah.
Filtering harmful data, fine-tuning with adversarial prompts, basically trying to trick the model using both human and AI-generated challenges,
Okay.
and using reinforcement learning based on feedback from humans and also AI critics. It's this continuous loop of trying to refine the model's behavior towards being helpful, but staying within safety boundaries.
And in terms of evaluating safety, what's truly innovative? I saw a mention of automated red teaming RT.
RT is really interesting. It's basically setting up AI attacker models to deliberately try and poke holes in the target Gemini model's safety.
Like AI testing AI.
Essentially, yes.
Yeah.
And crucially, these attackers work in a black box way. They just interact with Gemini using natural language, like a user would, no inside knowledge.
So it mimics real-world interaction.
Right. And this scales incredibly well. They can generate thousands of potential problematic prompts per hour across different policy areas, safety, tone, helpfulness. It massively speeds up finding and fixing issues before release. It's like an automated stress test.
That sounds like a powerful tool. What about security? Specifically, these indirect prompt injection attacks. What are those?
Okay, so imagine an AI agent reads your emails. An indirect injection attack would be hiding malicious instructions inside one of those emails.
Ah, so the bad instruction comes from external data the AI processes.
Exactly. It's designed to hijack the AI's behavior without the user knowing.
Yeah.
Very sneaky.
And how are they testing against this?
They developed automated ways to generate these malicious prompts using AI techniques like actor critic, beam search, and this tree of attacks with pruning, TAP. Basically, using AI to craft sophisticated attacks to test the defenses at scale.
And Gemini 2.5 holds up better.
Much better, according to the report. The attack success rate, or ASR, dropped significantly. For beam search attacks, it went from over 75% success on 1.5 Pro down to just 4.2% on 2.5 Pro.
Wow, that's a huge improvement in robustness.
It suggests much better defenses against these tricky, real-world manipulation attempts.
Finally, this frontier safety framework. Evaluating dangerous capabilities in areas like CBRN, cyber, AI R&D. What were the findings there? This seems really important.
Hugely important. The key takeaway is nuanced. Gemini 2.5 Pro did show a significant jump in capabilities in some of these areas. For example, solving tough cybersecurity challenges at an expert level.
Okay, that sounds concerning.
But, and this is the crucial part, it did not reach what they define as critical capability levels in any domain.
So, more capable, but not dangerously so, according to their framework.
According to their internal framework and testing, yes. It really highlights that ongoing challenge, advancing capability rapidly while ensuring safety keeps pace. It's a constant balancing act. They also mention external safety testing by independent groups, which adds another layer of scrutiny.
Right. So let's try and wrap this up. This deep dive really shows Gemini 2.x isn't just an incremental update.
Not at all. It's built on fundamental innovations. That sparse MOE architecture, the TPU v5p elasticity for training resilience, the sophisticated post-training.
And the new capabilities like deep think for reasoning, the massive leap in coding.
Plus the advanced safety and security work, like automated red teaming and the improved defenses against prompt injection. It's progress across the board.
So for you listening, what's the bottom line? What does this mean?
Well, it means AI isn't just getting incrementally smarter. The whole process of building, training, and evaluating these systems is becoming way more sophisticated, way more rigorous.
Which enables new things.
Exactly. Things like generating interactive lessons from hours of video, or AI agents that can actually help with complex research or coding tasks. It signals AI becoming a more powerful, more efficient, and hopefully more responsibly developed tool.
Indeed. And maybe a final thought to leave you with. As these incredibly capable models like Gemini 2.5 get woven deeper into our lives, how we learn, work, find information, what are the new ethical questions, the societal challenges that emerge?
Things that need more than just tech solutions.
Right. They'll need our collective human ingenuity to navigate. Maybe think about how these advancements could reshape how you personally learn or solve problems or just interact with knowledge in the years ahead.